All right, so today we're going to be doing lecture 23. This is going to be on nonlinear regression. And last time we did the regular linear regression, and every time we did that, we got some line on our screen. But this time our functions are going to be nonlinear. So just to review, a linear regression is going to have the equation y1 regressed against mx1 plus b, where m is the slope of the line and b is the y-intercept. So that's what we did on Monday. But today I wanted to take a look at some nonlinear regressions. So let's talk about a few of those. All right, so for nonlinear regression, the first one that I want to look at is the quadratic function. The quadratic function is going to have this form to it. It's going to be ax squared plus bx plus c. And I'm putting a subscript 1 on each one of my variables because that's what it needs to look like when you put it into Desmos to find the regression. Notice that the quadratic function always has a highest exponent of 2. We're also going to be looking at the cubic function. The cubic function is always going to have a highest exponent of 3. It's going to look a little bit differently than our quadratic. And we're going to have 4 different coefficients, A, B, C, and D, where all of those letters stand for real numbers. So then, after cubic, we're going to look at exponential functions. So exponential functions are always going to have 2 different numbers that we're going to be looking at, an A and a B. A is going to be the coefficient and B is going to be called the base. The base is the most important number because that's the number that we're going to be raising to the x power. So that's called the exponential function. And then the inverse of exponential is logarithmic, as you probably know. We're going to be taking a look at that today. The equation for a logarithmic regression is going to be a plus b natural log of x. So a is going to be the number that's added off to the side, but b is going to be the number that's in front of the natural log. And the ln, where the L is kind of written in cursive, that stands for natural logarithm. So that's what the ln means. And then a little bit later on, we'll be looking at a 4th type of nonlinear regression, and that's called sinusoidal. This function is going to give you a graph that looks like a wave. It's going to be y1 regressed against a plus sine. Let me put b in front of sine. Sine of x, and I'll put a 1 right there. So this is going to be our sine function, and when you graph it, it's going to look like a wave, kind of like this. All right, so those are the 5 nonlinear functions we're going to be looking at today. Let's take a look at the 2 problems that we have on the problem set. And what I'm going to do is I'm going to share my screen so you can see what Desmos is going to look like. Okay, so now you should be seeing my screen. I've got Desmos up, and I put all my functions on the left side inside of the boxes so that I can see the picture or the graph of the function on the right side. So let's do number 2 together. This is going to be an exponential regression. So the first thing I always do when I do a regression is I make a table. So I'm going to go up here to where it says the plus button up here. It'll say add item. And we're going to be choosing a table. So on the left side, I have x1. That's where all my x values are going to go. And on the right side, I have y1. And that's where all the y values are going to go. So we're going to put these numbers in for the x column. We've got 0, 2, 4, 5, and 7. For our y values, we're going to have 10, 44, 160, 320, and 1285. When you put the thousands in, make sure you don't put a comma where you think the comma should go. Because if you do put a comma right here between the 1 and the 2, Desmos is not going to recognize that, and it'll put up a caution flag. So we're going to get rid of all the commas. But decimal points are fine. It'll recognize that. So now what I want to do is I want to be able to see all my dots. So down at the bottom of box 1, there's going to be a magnifying glass with a plus button on the inside. This is called Zoom Fit, and we're going to click on that to see the dots. So I think the dots are perfect candidates for an exponential function. So what we're going to do is we're going to go down to box 2, and we're going to type in our exponential regression. The first thing that we need to type in is y1. So I'm going to put down a y and a 1. It's going to tell me that this is a 5-element list, just judging from the y values up here. But now I need the squiggle. And the squiggle is just going to be a symbol that we're going to use for every regression. To find it, I'm going to go to the ABC down here at the bottom. I'm going to click that, and then the squiggle is going to be on the bottom row. So I click that, and the squiggle is going to show up beside the y1. The next thing we need is our A and our B. I just need a lowercase a and a lowercase b. And now to make this exponential, I'm going to raise b to the power of x1. So to do that, I'm going to click on 1, 2, 3 down here. That'll bring me back to my regular number calculator. And I'm going to click on this a to the b power right here, right next to the a squared. And what this is going to do is it's going to raise anything to an exponent. So when I do that, the cursor is going to jump up to above the b, and we're going to type in x1. So now I have my exponential regression. We're going to leave the log mode box unchecked, because if we do check that, it's going to instantly make our function into an exponential function where the base is e. So I'm going to leave that unchecked. The next thing that I'm going to do is I'm going to plot my residuals, or my error terms. If you go down here to where it says residuals E1, you're going to hit the plot button. And then these red dots are going to show up on the x-axis. And that tells you the error terms associated with each ordered pair. So the last thing that we're going to do is we're going to write down our r squared value, which is 1. I'm getting that from right here. It'll be under statistics. R squared is the determination coefficient, and it's going to tell you how good our regression line is going to be. And down here, you'll see parameters. And it tells you that the parameters may not be exact. And that's because it's always going to be an approximation when you're doing regression. It tells us what our A value is and what our B value is. So down here in box 3, I'm going to type in f of x. Go ahead and type in f of x. That's going to be our function notation. And we're going to type in equals. And the first number that I'm going to use is my A. So my A is going to be 10.0073. That's going to be my coefficient. And then what I'm going to do is I'm going to use parentheses. And on the inside of the parentheses, I'm going to type in my base, which is B, 2.00087. That's going to be the base for my exponential function. I'm going to close that up so the entire number is inside parentheses. And then the last thing that I'm going to do is I'm going to raise it to the x power. So opening up my keypad, I'm going to hit the A to the B power button, and I'm going to choose x. That'll be my exponent. So now I've got my exponential function that matches my regression exactly. Okay, so that's my function. What I want to do now is I want to predict what y is going to be when x is 8. So if this chart up here was to continue with the x values, what would the y value be if the x value is 8? Well, it's easy to figure that out. We're going to go to box 4, and we're going to type in f of 8. And what you'll notice is I'm replacing the x with an 8 because that's going to be my new x value. And then it'll spit out the y value at the bottom. My y value is going to be 2,571 because I'm rounding up. So that's how you can make predictions. And to make predictions, you're always going to need your function in function notation. That's very important. Okay, let's look at a quadratic regression. So I'm going to hit the X button on all of this. That's going to make everything disappear. And I'm going to make a new chart or table. I'm going to hit the default zoom right here. It'll look like a house. And it'll bring you back to your default window. So for this one, I'm going to do number 1 on the problem set. The X values are going to be -5, -3, -1, +1, and 4. Make sure that's a 4 at the bottom. Our Y values are going to be 502, 183, 25, 22, and 320. So now that I've got all my numbers in, I'm going to hit the zoom fit button at the bottom of the box. This magnifying glass is going to zoom in on our dots. So it's going to resize the window so that you can see them all. The next thing that I'm going to do is I'm going to make a quadratic regression. So for a quadratic regression, we're going to use y1 and the squiggle. And we're going to type in a x1. We're going to square that x1 plus b x1 plus c. So notice we now have a quadratic regression, and this is going to be a U-shaped graph that best approximates all the data. My r squared value is 1, And it's going to tell you what our A, B, and C coefficients are at the bottom. And I'm going to plot my residuals by hitting the plot button. The next thing that I want to do is I want to make my quadratic function. So I'm going to go down to box 3, and I'm going to type in f of x equals, and then I'm going to type in a. I'm going to use all the decimals that it gives me. I'm going to multiply that by x squared. And then I'm going to use a minus because my b number is negative 0.386006 times x plus c, which is 3.53399. So now I've got my function. I'm going to click into the box 4, and I'm going to predict what happens when x is 10. So I'm going to type in f of 10. And it tells me that when my x value is 10, my y value is going to be 1,986 if I round that 5 up to a 6. So that's going to be my predicted y value. Now I can make this an ordered pair. You can actually write down an ordered pair in Desmos. It's pretty simple. You just need to have the parentheses and an x value and a y value. So I'm going to type in exactly what I see for the answer that I just got. And then if you zoom far enough, you will see your dot up here. So that's how you can make predictions using statistical regressions. Okay, so going back to our slides right here, we're going to be using all 5 functions to do our classwork today. So what's going to be due on Sunday? You're going to have 2 assignments. You're going to have your linear regressions. I call that linreg. And you're going to have nonlinear regressions. And you're going to do that today. So that's all I got today. Class dismissed. If you have any questions, you can leave them down in the chat box, and I will get to you very shortly. Have a great day. I will see everybody next week.